Hi everyone, my name is Burke and this is my midterm presentation for University Accountability Ordinance Project. This project analyzes data from Boston's University Accountability Ordinance, which requires universities to report off-campus student housing information each year. The main goal is to understand how student populations affect Boston's rental market and to identify non-compliance patterns among landlords and properties. So far, I have focused on building and property violations data set, which contains around 17,000 records from 2016 to 2024. The data comes from the City of Boston Open Data Portal. For this stage, I have loaded the building and property violations data set and set up placeholders for others like 311 service requests, property assessments, and UAO address reports that I'll integrate later. In processing, I've cleaned and standardized the violation data, fixed missing values, extracted the year from date fields, normalized the addresses, and created severity label based on a text description of each violation. This gives me a clean table where each record has a year, type, and a severity level ready for analysis. Now let's look at some early visualizations. The first chart shows violations per year from 2016 to 2024. You can see there's a steady decline after 2018, which might reflect better housing compliance or changes in inspection activity. The second chart shows the top violation descriptions. The most frequent ones are failure to obtain permit, unsafe and dangerous, and maintenance. This gives us a sense of what kinds of issues dominate Boston's housing enforcement records. Finally, here's the violation severity distribution. Most cases are minor administrative, but about 10% are severe. Things like unsafe structures or fire hazards. This helps us understand the overall seriousness of violations across the city. Now we have some model results. I built a logistic regression classifier to predict whether a violation is severe or not using only the text description and a few categorical features like year and ward. The results were extremely strong, accuracy of 0.996, precision of 0.989, and an AU ROC of 1. This ROC curve shows near perfect separation between the severe and non-severe cases. That tells us the violation text alone contains strong linguistic signals of severity. For example, words like unsafe, fire, or electrical almost appear in serious violations, while maintenance or trash described as minor ones. And here's the ROC curve that the model has, and this is also the precision recall curve for the logistic regression. All of the graphs that are shown here are available under the visualizations folder that is under the notebook folder. Moving forward, I'll integrate 311 complaint data, property assessments, and student address data from UAO reports. That will let me connect violations directly to student housing and detect clusters of non-compliant landlords. I also plan to build a spatial map of violation density and experiment with models like gradient boosting or clustering to predict future non-compliance risks. To summarize, this midterm milestone processed and analyzed 9 years of Boston's housing violations, created clear visualizations, and trained a high-performing baseline model. These results show that the data is consistent and meaningful and provide a solid foundation for deeper analysis in the final project. Thank you for watching.